Hey everyone, welcome to Backend Study Group session with Women Who Code San Francisco. A little bit about us. Our mission is to empower women to excel in technology careers. We started the Backend Study Group a couple of years ago, where we teach backend engineering concepts pretty much every month. I am Prachi Shah. I'm a senior software engineer at Unity and also director at Women Who Code San Francisco. And Anjali, you want to introduce yourself?
Sure. Hi, my name is Anjali. I am the lead at Women Who Code San Francisco and also the host for the tonight session. So these are the following agendas which Prachi will go through during the presentation. So to you, Prachi.
Yeah, thank you. So yeah, we have a lot to cover today. Let's get started. Just a little bit about backend engineering, computer science is wide, but backend engineering is very specific in that we design, build, and maintain server-side, primarily server-side web applications. Some of the concepts that are part of backend engineering is understanding client-server architecture, networking, APIs, web fundamentals, microservices, database security, operating systems, and a lot more. If you think about tech stacks, Java, PHP, .NET, AWS, NoSQL, all of this would be considered like backend technology stack. So SQL, so basically SQL stands for Structured Query Language. It is a standard language for managing and manipulating relational databases. And by relational, what we mean is there is some kind of relation between different data points. And that is what SQL is designed to basically manage and manipulate that kind of data. It allows you to define, manipulate, and query the data stored in a database. A little bit history would be, it was first developed at IBM in the 1970s and was initially called SQL, but now everyone just calls it like SQL or SQL. It became the standard in 1986 and so forth. There are different versions of the core language that have been evolved, MySQL or Oracle also has relational database, so SQL Server or Postgres it also has their own relational database. So you can use different products from different companies, which will be your SQL database or relational database. So queries, so basically SQL queries consist of one or more statements that instruct the database on what to do. So think of SQL statements as commands. You have your relational data stored in a database. Now you want to basically start querying it. You want to give a set of commands to understand or analyze the data that you have in a more meaningful, in a more structured manner. Some of the most common SQL statements are select, insert, update, delete. Select basically helps you read from the database. A database consists of one or more tables. A table basically consists of rows and columns, which is how you store your data. So select lets you read the data or retrieve it from the database and to display it on your chosen IDE. Insert lets you insert new records or new data points in your table, one or more tables. Update lets you modify the record, right? Data changes over time, so you want to keep your data storage updated. So that is what the update command is for. And delete, you don't want to always store all the data, or there's obsolete data that you don't care about. You might want to delete it to save space or to save costs. So delete will let you do that. Data manipulation language. Okay, there are primarily two kinds of queries in SQL. First one is data manipulation language, and the second is data definition language. So data manipulation lets you retrieve the data, insert, update, delete, right? Common commands are the ones we saw: select, insert, update, delete. Data definition language focuses on the definition of the data, the structure of the data and database objects. So it lets you create objects, create tables, alter the table structure, delete or modify the table structure. So it focuses on the structure of the data, or the definitions of the data, right? So you can create a table or alter the table or drop the table. You define a structure and then you insert data in it. So most SQL commands, they are defined into either DML or DDL. Some of the common SQL commands or statements or queries would be, select. It is used to query data from one or more tables. And this is the structure. You select column 1, column 2 from a table where there's some kind of condition. We'll look at conditions a bit later. But one example is, select star. Star means all columns. Select all the data from the employee table where salary is more than 50,000. So we care about all employees whose salary is more than 50,000. This is a DML kind of a statement because this is considered data manipulation. Insert statement is you insert new records into a table. Now you can insert multiple records. So here the syntax is insert into the table, name, column. So column 1, column 2, so it can be like, hey, insert into customers, enter their name and their email. And values tells us the value that we want to insert for that column or that data point. So in the example here, we are inserting a new one new customer into the customer table. We are putting this customer's name and value, and then name and email, and we are also providing the respective values. This is again a DML statement because we are manipulating the data, we are modifying the data. Update statement is where you already have an existing data and you want to modify. This is different from insert. Inserting is adding new data. Update is something that you already have. Now you want to modify it. Right. So the syntax is very clear. Update into the table. You use the keyword set, right? And you set some value or some column to this new value. And you can use the where clause, right? Like only where the product ID is 1, go and change the price because the price of this product has been changed now. This is again a DML statement or command. Delete statement is delete the record, right? You want to delete, you can delete like all the records or you can delete specific records. There can be a condition here as well. Like in this example, we have a condition, you delete from orders table, right? So you don't have to like necessarily specify, you'll be deleting here everything that all the records where the orders were before, I guess, 1st January 2023, right? Any orders made before this date, less than tells us before, right? Before this order date, just delete everything. I don't need to store this data on my orders table anymore. So you can use different conditions, and this is a very simple example, but this queries can get quite complicated. That's why learning SQL or attending SQL interviews is like, we will look at the advanced level later in the session, but it can get quite complicated. SQL is might not be always very easy to understand. This is a DML statement as well. If you look at the DDL statements, we have create, alter, and drop, right? The create statement is used to create a new table in the database. And the syntax is create a table, specify the table name, and specify all the columns and data types that you want to be a part of this new table. So you're defining the structure. So in this example, we are creating a table employees. We want it to have the ID column. It should be of data type integer or int, right? We want the name, which here means name of the employees. It should be varchar 50. So in the names do not exist 50 characters, right? You can make it to 255. You can make it to 100. You can specify that. Salary, we want to add that, and that should be like decimal, and it should be 10 to 2 digit, right? So this is decimal. So you can specify that. And this is a DDL statement because you're defining the control or definition of or the structure of a table in the database. This is again assuming that you already have a database. Like once you download SQL, you install it, you might want to first create a database, then use all these statements to create, alter tables within that database. You can also have multiple databases, right? So as your application or your project grows, you can have different databases that have different specific data stored in it. Like, for example, I have a database that stores employee information. I have a database that stores product information. I might have a database that stores analytics information. And they have their own set of tables and structures and everything. And it's totally fine that your one application is dealing with all different kinds of databases. So it's totally possible. And SQL lets you do that. Any SQL tech stack will let you do that. Alter statement is used to modify the structure of an existing table. So let's say in the employees table, right? Like I did not add email. We were not collecting emails initially. Now we care about storing the employees' email. So what am I going to do? I already have a table. It has data in it. I'm not going to delete the table. to create a new table with emails in it, like where does the data go, right? So you can modify the structure of the table. So for this existing table, I'm just going to go and add a new column, email, and then I'm going to start collecting emails and storing that data for every new employee that I have, right? It's also possible that all these employees that I have in employee data that I have in the table already, I'm going to now go back and update their emails because now I have that column. So that is also possible if that's something that we need to do. But yeah, you can modify the structure and add a new column. You can add as many columns as possible. So here we are adding the email column, and the limit for that character limit is 100. And again, it's the DDL statement, right? We are modifying the structure. Drop statement is you want to drop the entire table, like you're collecting certain information about, let's say, your users or customers, and you don't need that information anymore. Storing data in the database after a point becomes expensive, and your application needs to mature to deal with different data, different tables and different databases. And if you're not storing any valuable data, it is important that you delete that or drop those tables from your database, because it adds up to space and cost, and also complexity and even performance. Query execution can also slow down. So if you don't care about certain table or data, you should be okay to drop that table and the data entirely. And this is the syntax: drop table, table name. And again, this is the DDL statement for sure. Since we are looking into like SQL, it's import queries, it's important to understand the data types, because especially for DDL statements, DML statements, you want to understand what data types, this is basics, this is foundation, right? What data types each SQL, what data types exist in SQL, and like Postgres might support a different data type slightly than Oracle, but we need to understand like the basic foundations, right? Like what does data type mean here? And these are some of the ways we can store data. Every data point has to have a name and a data point, a data type to identify it. So basically, this is the kind of data we want to store in a column in a table. Common data types are your integer values, right? It can be for the ID column, for example, your varchar, where n is the size. If you see, we had like email was size, varchar 100 character limit. I think name was 50. So you can define that. I think maximum is 255. So it can be anywhere from 1 to 255. But if you use this data type, which is variable length characters, you can, between the 1 to 255, you can decide the size. And the database will ensure that the size limit is that value or that rule is respected. Character is fixed length again. The difference is the storage in the memory. Character takes less storage than varchar. Float is for floating point numbers or numbers with decimals. Usually date has a different format, so you can define the timestamp or date formats. Boolean is true or false. And these are just some examples, if you want to define integer, then example would be like, hey, like age is a column, integer is the type. I'm adding quantity as a column, integer as a type. So here are just some examples on how you can define your data types. One second. Yeah, there are some more examples here for character, float, Boolean. There's also one data type called blob, which just stores the images and files in your database, and or documents for that matter too. If you have small documents, you can totally store them in relational databases. You don't need to necessarily go for NoSQL databases. So blob would be the data type for such a file like image or document. Clauses is something very important in SQL, because it helps you come up with conditions for data retrieval, and it's more advanced data retrieval and manipulation. There are some kinds of clauses that are very foundational, like join. You have two different tables, you want to query them collectively. You can query two different tables at the same time and using the join function. We'll look at it bit later. Group by is basically you group different rows based on a column and perform like some set of aggregate functions on that group data. Having filters result sets based on like those aggregate functional conditions. Where is, like you want a specific kind of data. So what does that specific condition mean? You can specify it using a where clause. Order by just source the results based on the column you want. So let's say I want all employees, but I want to order my result based on the ID, right? Start from employee 1 to 10 or ascending or descending. So I can totally do that. That would be my view of the data, right? Group by is you just group rows based on 1 or 2 columns. You can basically structure the data like that. Here, one example is like, you select name, then you select sum of all the salaries in that from the table, and that sum will be called total salary. It will be the new column just for your view, not a new column added to your table. From the employees table, where we want a sum of total salary of everyone whose age is about 30. Right, and then you want to group them by name. So just like make sure that my view has the order by name, and we also want to make sure that these people are over 30, but the total salary is about 50,000, and that is the view we want. Right, all employees about 30 and total salary about 50,000. So that will be your query. Here we are basically selecting the name and calculate the sum of employees over 30 years old, and then we are grouping them by, and then also ordering the results, just to have a proper view. Bear in mind that order by, group by, all of that helps us give a more sophisticated view of the data. You are here not modifying the data, right? We have a select statement. Yes, like here we in fact actually even created a new column called total salary just for a view, because I just want to see, that is my column. If I export those results, or if I take a screenshot of that, that is my analytics of the data, right? But I'm not created a new column called total salary. I just want my results to be named, right? So that is what we are doing here. And clauses let you do all of that. Functions. So functions is also something very important in SQL. There are some built-in functions provided by SQL language where you can do certain operations on data and return computed results. There are 4 types of functions: aggregate, string, date, and mathematical. Aggregate functions are average, right? So you can calculate the average value of a column. Let's say I have like, I have an employee table and I have 5 employees in it right now, and I have their salaries, and I want to understand, like, what's the average salary of my employees. I'm just going to run this function on the data on the salary column and be like, okay, this is the average salary or income my employees have. Some would be, again, addition. Count would be, you can count the number of rows or columns in your table. Minimum just tells you, hey, I looked at all my data, give me the minimum value or give me the maximum value of the data in my database, in my table. And string functions is different. It helps, this was like more on numbers. String functions helps you deal with strings or varchar or characters, where basic functions, right? Like concatenate 2 strings, get a portion of a substring. So let's say you have a column of type varchar. Now you want to just like find the substring of the value, right? Find me all the string values which have the word max in it. Fine, okay. That's something so simple. You can find that using the substring function. You can also convert strings to upper, lower value. You can get the length. So these are some of the very basic functions you can do on your data. One example here is, like I said, calculate the average salary of all my employees. You totally do that. The database will give you the result. Date functions is now tells you the current date and time. It's like, if you want to query, you have some application running and logging and this kind of stuff is happening, you can always be like, okay, select start from this table with date time now. So it will just tell you that what is ongoing right now, what data did you collect now. So you can just query your data as well. Or if you want to add a new record to the table and you care about the timestamp, then you can also be like, okay, insert new information in my table with the timestamp now, which will just tell us the current date and time. And that is what will be inserted into the table. Date just extracts the date time, date portion of the date time. So date time basically consists of your date and timestamp, and you can also define the time zone, UTC or GMT or whatever, right? So that is a complete format. You can, it's the simple date format, which has a date and time or timestamp. But if you just care about the date or just the year or just the month or just the day, you can use these functions to extract just those specific values from a date type of data point. Mathematical functions are also very important. This is when you do some advanced querying also. Like you can get the absolute value of a number. You can round to your decimal places. You can ceiling, right? The nearest integer, floor. You can raise a number to a power. So this will like, you can do a mathematical function here, basically select power 2 to 3. It'll give you the result of 2 raised to the power of 3. You can do mathematical functions within your SQL as well. One example would be, hey, like get my salary and you raise that raise that value to 3. I can totally do that kind of math if I want to, even on a column value. Here is just giving me the result of power 2 raised to 3, which is just a simple math function. Operators are also something very important. SQL is extremely powerful language. Like you can see, like it lets you do a lot of stuff. String functions, date functions, even mathematical simple math functions you can do in your SQL editor. You can do all of that with your data. It's actually extremely powerful language. No wonder every corporation, every company, they deal with relational data, and everyone's using SQL query language for data analytics, data engineering, data manipulation, you name it. It's quite powerful language, and also performance-wise, query execution-wise, it's actually pretty good. No wonder it's been around for like, what, 40 years now. So a lot of good features. Operators are symbols or keywords used to perform operations on data, right? So you compare different values and you do certain kind of operations between 2 or more operators, right? So very simple. There are arithmetic operators, which lets you add, subtract, multiply, divide, do modulo division, right? And the symbols or operators to the left are what you actually use. Comparison operators are equal to, not equal to is either like the angle brackets, or not equal to, less than, greater than, or less than, greater than, equal. So you can actually use these operators in your SQL queries for data comparison. Logical statements are your basic logical and or not functions. You just use the and or not keywords to do a logical and, logical or, logical not, respectively. If you want concatenation, you can use the double lines as well for string. If you want to use an operator on string and you want to do concatenation, this is your option. There are some examples here. Arithmetic is select 5 plus 3 will result in 8. It just is simple math, right? And we use the plus or addition operator. Comparison would be like less than, equal to here, right? Get me all the salaries less than 50,000, equal to 50,000. Logical is getting all employees where age is 30 and they are in the IT department. So I want both. That's my condition, right? That's my operator. String kind is like, select stars, select all the columns, all the data points from my products table where somewhere in the description, I have the word Apple. So if you see here the percentage before and after, it is just string matching. So look at my products table, get me all the data points where in just the description column, the word Apple is mentioned somewhere. It can be the beginning, it can be the end, it can be the middle. So like, all the Apple products, just return that to me. So this is where, we are using the string manipulation, basically. Relationships, this is very important. SQL is a relational database. There are non-relational databases or NoSQL databases that do not care about relationships between data points. You can just store documents or like images and stuff. Images don't have relationships with each other, but in a SQL table, an employee might have a relationship with a department table or something else, right? So like, if you have data points like banks, right? Banks, like your bank account, you care about account, you care about profile, you care about like investments, you care about login. You can create tables for all these different data points, and they're all linked by, let's say, your bank account number or your SSN, stuff like that, right? So this is related data. Relationships, SQL lets you store and manipulate a relational database or relational data. There are different kinds of relationships here. Understanding this will help you design better tables better columns, better structures, and that will in turn help you with performing better queries or better analytics on your data. And as your data evolves with time, it will just be more easy to manage your data as well. One-on-one relationships, right? Each record in table 1 is associated exactly with the same record in table B and vice versa. So like a person table can only have one address, and one address is probably associated with only one table. But that might be here association of a person to address is 101. But address to person might be one too many, but we'll look into that. From the perspective of like one person only has one address, they only live in one apartment or house at a time, right? So that is your one-to-one relationship, direct correlation or direct relationship. One-to-many would be like each record in table can be associated with multiple records in the other table. But each record in table B is associated with only one record in table A. So that works both ways. Like a department table can, and an employee table where one department can have multiple employees, but an employee is only associated with one department, right? So this is your example of like one-to-many or one-to-n. And n can be 1 to 2 tables, 1 to 2 or 1 to 3, whatever, right? Whatever your association or relationship you want to define in your database. When you're designing a database, when you're designing a table, when you're designing an application, it is really important to understand what data you're dealing with, what data you're going to capture, and what is the relationship between your data points. Like if you're designing like a, let's say like a university application, you will have a department, you will have an employee, you will have students. What is the relationship within like department table versus employee table or department table versus student table? You need to be very clear on what those relationships are. And that is only after that you can design these schemas or design your tables as well. Many-to-many is like each record in table is associated with multiple records and vice versa. So one example would be like, a student can take multiple courses and one course has been taken by multiple students, right? So that is many-to-many. It's fairly straightforward. For us to define, now this is like a theory, right? But how do you actually like define a relationship? Right? So there's something called primary keys and foreign keys that help you establish relationships or linking between different tables and or different data points. Primary key is like a set of, it's basically identifying a column in your table. Every table needs to have some basic unique identifier. It can be the ID column. It can be, usually every table has some kind of ID column or identifier column. Usually that's the primary key. You need to come up with basic column or data point which identifies your table and which identifies every column in your table, every record in your table, right? Like if I have an employee table and each employee has a unique employee ID, right? That can be my primary key. Every data point, every column, every employee in my employee table is uniquely identified by their employee ID, right? It's different. Two employees can have the exact same name, but they might not have the exact same employee ID, right? They shouldn't. So that is my unique identifier. Each table should have one, and primary keys are unique. That means they're non-repeated at all. There can never be primary key, two columns, which is primary key, they can never have the same value ever. And they will never be null. They always have to be populated, right? And they are usually int or character. Employee ID can be like, like integer, like 1, 2, 3, 4, 5, or it can be like 1, 2, 3, 4, 5, ABC. That would be varchar, but that's my employee ID, for example. Foreign key is a column or a set of columns that reference the primary key. So, for example, like my employee ID, my employee is a part of a department. I can have a foreign key in the department table, which links to the employee, right? So this employee is a part of that department, something like that. So basically it establishes the relationship between these two tables or these two entities, right? Entity meaning employee and department. So it establishes a relationship between two tables based on common key values. Here it's the employee ID, let's say. Foreign keys, there is specific constraints or rules you need to follow if you're defining foreign keys in your table. Basically, a foreign key only exists if it's linked to a primary key. So you need to make sure that every table has a primary key, and based on that primary key, you're assigning the association, right? So that is your referential integrity that you need to maintain. Foreign keys can have null values if the relationship allows it, right? There is a possibility that you join, an employee joins and they're not assigned a department yet. In that case, there is no department assigned to them. And in the department table, we might not store information about this employee. Once they're assigned the department, then we can be like, okay, now we have an employee and this is their department, right? So it can be null because we have not established relationship yet. Now, this is the real world example, right? Like somebody joins the company and they don't know what team they're going to get into yet, right? So they're still an employee now, they've still joined, but no team is assigned because they're still going to, let's say, onboarding. After that, they'll be assigned a team, right? We still need to figure it out, right? So it can be null. Once the project is assigned, the team is assigned, then that table, project table or team table, now you have this association. Now they are part of the team or project. So those can be null because there was no relationship before. Now there is one. And this is how this is a real example, right? So you should make sure that data is designed, your schemas are designed, the relationships are designed in a way that this is possible. Foreign keys can be used to establish different types of relationships, right? One-to-one, one-to-many, many-to-many. You need to understand what relationships, what data you're storing and what relationships you have. So you can design the primary key, foreign key primarily, but you can design these relationships properly using foreign key. You need to have that clarity within your application, even a real life example, before you go ahead with defining and implementing relationships. We looked at joins before. I want to get back to that. Like joins help you query data from more tables at the same time. Usually if you do select star from employee table, well, salary is greater than 50,000, you're only querying that table, right? But what if I want to do some analytics? I'm storing a lot of data in my database in different tables, and they are probably, if it's an employee database, I'm storing different information in different tables about employees, right? Employees at a company, employees, at a university, whatever my application is, right? But I'm just going to go with generic term employees. And I want to query different, I just want to do some analytics. Now, why do I need to go through every data, every table, every column and understand what is going on? No, I have SQL queries for that, and I have joins for that. That will give me a more structured view of my data. So there are really different kinds of joins. The first is the inner join, which only returns the matched or common values from both tables, right? So let's say sometimes, depends on the design, your application, the data, but sometimes you have different tables in the database storing similar or same values. Okay, like every time I'm storing every table in the employee database, I have to store, let's say, the employee ID. I have to store the department ID. Let's say I have to store email address. So that's kind of repeated. And if you want to just find the common values between matched rows between different tables, you can do that. So in this example here, we have two tables, employees and department. They have their own set of information stored. And basically, this query will join the employees and department table based on the department ID, right? Because that's what's common between the two, right? And retrieve employee names and corresponding department names. So because we can join these two tables on one column, which is department ID. Now I can get the department name and employee name or employee ID. I can query that from both tables. So I'm joining the two tables on the common column, department ID. And based on this, I can read from two tables. I can get the department name, I can get the employee ID, I can get the employee name. So this way I was able to read from multiple tables, and I don't need to query these two tables twice. I just join them and based on a common value. And I was able to read all the columns basically in this example. So that is pretty powerful. The other kind of join is like a left join, where you still join two or more tables on the same common column, but you only care about results from the first table. That's left join. If you care about results from the second table, that's right join. So you can define that. Like, this query, in this example, query performs a left join between the same tables, but retrieves only employee information. We don't care about department information, right? So you do a left join where, you care about like employee's name, but you only want to like, you want your data based on the employee table. Right join would be you want join between the employees and department and retrieve all department names along with employee names. So you care more, you want the view based on the department table or department, the data in the department table, and you can use the right join. So you have to specify like the keywords, the right join or left join. If you just do join, then it's gonna like, based on what you select, it's gonna just return you that. So this can be more, left or right join is like more specific. Nested queries. So far we have only looked at like one query, right? Select something, insert something, update something. This is one command or one statement. But nested queries, also known as subqueries, let you run multiple queries. So like, it's like, you can select, you can insert, update all in the same one big query, and nested queries let you do that. They are used to retrieve data from one table based on the results of the another query. So you can be like, okay, select like all the employees from employee table where let's say your department ID is 1, and then go ahead and update all of those results to something else. Let's say the department name changed. Now we have a new department name associated with department ID 1. You select all the employees where department ID is 1, and then you go ahead and update their department name, right? So something like that. That will be a nested query or subqueries where you're doing select and update at the same time. And nested queries let you do that. So you run one query or one function, and that lets you do multiple things. And SQL is kind of very powerful in letting you do that. If you understand the data, if you know what you're doing, you can completely like accomplish 2 or more tasks using one nested query. And there's a structure on how to do that. You have to like select certain things, and then you have to select the data first, and then you have to like execute on that data, right? Or manipulate that data. So that is usually the structure. Yeah, so nested queries or subqueries are queries within another query, right? They used to retrieve data from one table based on the results of the other query. So in this example, like retrieve employees from the sales department, right? So I'm like select employee name from employees where department is so-and-so, but how do I, department ID would be another select query. So like, how do I get the department ID? It's another query. This query will populate the department ID. So, like, what's the department ID of the department named sales? Find that ID first, and then select all the employee names. So basically we want all the employees in the sales department, right? That's what we are trying to do. And we can have multiple queries. So this is your subquery within a query. Usually there is some kind of select because you want a view, right? You want to see the data. We want to analyze the data. We want to see it. But it's a very simple example where we're just doing select. We're just retrieving the data. We're not making any changes to the data. So you just want everyone you just want all the employee names in the sales department, right? I don't remember all this department IDs in my database, right, in my table, but I know that there is a department name called sales because I understand my application, right? So I'm going to be like, whatever the ID is of the sales department, get all the employees for that department, right? Because in my employee table, I'm not storing the department name. I'm only storing the department ID. I don't know what department ID 1 means or department ID 2 means, right? But I have one employee name, so I have to query the employee table, but I don't know the name. So therefore I have to query the department table for the ID, which is sales department. And then whatever that value is based on that, it might be 1. Okay, fine. Find all the employees in department 1, right? In this table. So I'm querying this table, but I need to have more data, and that is where this nested query or subquery comes. So this gets executed first, and then we get the result, and based on that result you get and then this select statement gets executed next. And so SQL will do it for you. It understands it's a nested query. It will retrieve the department ID first, that is your condition, and then the where clause or that where condition is met, and based on that value, you will get all the employee names populated for you. And like nested queries are quite powerful. If you want to do some advanced analytics or make more sense out of your data or retrieve your data in more intelligent ways, nested queries is quite powerful. I'll let you do that. So we are at the end of the session. I hope this was a very good introduction or a complete, I guess, overview of everything that SQL is. All these concepts, it can get quite complicated depending on the kind of data you have and the scale, but it gets very interesting. That's where like knowledge of advanced SQL or practice rather comes in. But any application deals with data, usually relational data. So knowing these core concepts is foundational, and you should always be familiar with these concepts. We have more sessions coming in the upcoming months. All of the sessions are mentioned here. If you're interested, do join us. This presentation is available on our GitHub repo, WWCode San Francisco GitHub repo, and this recording will be there on our Backend Study Group channel on YouTube as well, so you can always refer. A little bit about us, like there are technical tracks, digital events. Feel free to subscribe to those. And we also have a Backend Study Group Slack channel. I can share the link to that Slack channel. Anjali, if you have it, you can share. Otherwise, I will share all these resources in our Zoom chat.
Sure, I'll just do it.
Yeah, now would be a good time for Q&A. Yeah, thank you, Alice. I really appreciate it.